Welcome back to the classroom. This is Mr. Wong speaking. We're going to go through an exam question paper. This is from the 2019 Independent Physics paper. Question 22, worth 3 marks, and it's also going to look into Module 5, inquiry question number 3. This is going to be about motion in gravitational fields, so let's begin. The space satellite Magellan was launched by NASA in May 1989 and put into a circular polar orbit around Venus in June 1990. The period of the orbit was this value here. Given the mass of Venus was this, calculate the radius of this particular satellite's orbit. So we are using Kepler's law. R is what we want to try and find. So what we'll get is, we'll do our substitutes down here. So it's r cubed equals to gm times t squared equals to 4 pi, and then root this or cube this over. So let's do our substitution. G is 6.67 times 10 to the minus 11. T squared is the period of orbit, so that's what we have there. We also have the mass of Venus, which I almost forgot to add, which I also am running out of space to write, so just managed. And then what we have is 4 pi square. So looking at the values, let's round it off to 3 significant figures and see what we get. Don't forget to put your powers in squares in your calculator. Okay, so I get a orbit 6396627.912 meters. That's exact, so forget about the round off. If I was to round it off to 3 sig figs, 9 rotated over, so 0.00000 meters. That's the length of the orbit. It's about 6.4 million meters. Okay, so let's move on. Question B, it says, explain why a polar orbit was used for surveying the surface of Venus. So when we look at polar orbit, that means the satellite is going from this side to this side. So from one pole to another, rotating around the globe like that. Okay, and the main reason being, if you actually consider it, so if we were to do this instead, so we go around a specific point of the latitude, specific latitude, it doesn't really give us a clear understanding of all the different environments. If you think about it, on Earth, we have our equator, then we have the tropics, and then we have, the North Pole, the South Pole, very different environments to each other. So if we were just to do it horizontally or geostationary, so to speak, we wouldn't be able to find a really diverse amount of environments to observe. By doing it polar, we actually expose our satellite to all the different types of environments that could be existing on Venus. Okay, so by using a polar orbit, it allows us to see the different surfaces of Venus from the changes in its environment as the satellite moves from one pole to another. Okay, and that's how you do the question. If you found this video useful in helping you understand these sorts of questions, give it a like, subscribe if you haven't done so already, and I'll see you next time.